Good day, grade 9s, and welcome to mathematics. Today we're looking at the parabola and the hyperbola. The parabola has a standard form that looks like this: y equals ax squared plus bx plus c, where x is the elements of real numbers. We are going to do an example that looks like this. When we do the parabola at the moment, the easiest way to do it is to use a table. So we take the table just like we do for any other graph, and we substitute the values for x into the formula given to us. If we look at the standard form and compare it to what they've given us, we see that our formula does not have a plus bx plus c. That means absolutely nothing at the moment, except that b and c is 0, and therefore we are left with x squared. So let's substitute our x values into our formula and get our answers. So this one is quite easy, it's just squared, so take the number and square it. So the square of negative 3 is 9, therefore our first number is 9. The square of negative 2 is 4. The square of negative 1 is 1. Square of 0 is 0. Square of 1 is 1, and square of 2 is 4. Square of 3 is 9. Therefore, if we look at our table, our lowest value for x is 0, our highest is 9, for y, and for x we start at negatives as well as positive. We can do this because we have real numbers, okay? So let's draw the parabola. If we take our table, we can set up our Cartesian plane and we can start plotting our numbers. Please excuse my graph. I know it doesn't go up to 9, but you can see there's a blue line for 7, and then 8 would be around there, and 9 would be there. So for negative 3, our first point would be 9. For negative 2, 4. For negative 1, 1. For 0, it's 0. 1 is 1. 2 is 4. And 3 is 9. So that is all our points for our first parabola. Now we need to find out, is this a solid line or not? So our first restriction said x is an element of real numbers. Therefore, it means that x can be any number. It's not, as long as it's not an imaginary number. So therefore, we can draw a solid line connecting all the dots with our pencil. This line is continuous. Okay. The shape of the parabola depends on the value of a. If a is larger than 0, it would be a positive graph. If we just relate that to being positive people always have a smile on, therefore a positive parabola has a smile. Yay! And opposite to that, a negative negative parabola always has a frown and looks like that. So that is just the basic form of shape of the parabola. Very important to know that it relates to the value of a. Let's draw another parabola, as I want to show you what to do when your restrictions are different. So when I give you the restriction that says x is an element of whole numbers, integers, and natural numbers, take that information and use it to set up your table. So for this one, it's whole numbers, and whole numbers start at 0. Therefore, whole numbers are 0, 1, 2, 3, 4. It does not include decimals or negative numbers, and therefore we can't start our table with negative 3, negative 2, and negative 1. Therefore, we start our table at 0. 0, 1, 2, 3, 4, 5, 6, and we complete this. Okay, so our original formula for a parabola said x squared. So we are clever enough to say 0 squared is 0. 1 squared, 1, 2 squared, 2, 3 squared, 9, 4 squared, 16, 5 squared, 25, and 6 squared, 36. Now let's place that information on our graph. Before we draw the graph, let's see what are we supposed to have on our graph. X values have to start at 0 and go to 6. Our Y values start at 0 and end at 36. That's quite a large number. Then I promise you there's not even as many lines on your page. Therefore, we need to make another plan. So the easiest is to change the our y-axis to count in a different interval. So if we can't count in ones, why not count in twos? 2, 4, 6, 8, and in the 38 there we have our 36, and our graph isn't a whole full page full. So now we can plot our points. So for 0 it was 0, for 1 it's 1, for 2 it's 4, 3 is 9, 4 is 16, 5 is 25, and 6 is 36. After we've plotted our points, now we go back to look at our restrictions. Our restrictions say it is whole numbers. Therefore, it can't be decimals or negative numbers. So these numbers that fall in between these numbers are not included in our graph. Therefore, this graph is discrete. So the only way we can go on from this is to make a dotted line and an arrow that goes up. Why can't we put the arrowhead that goes down here? Because x is an element of whole numbers. X can't be smaller than 0. Therefore, our graph literally only starts at 0 but ends at infinity. Next, we look at the hyperbola. Sorry for these, you'll understand them now. Okay, so the standard form of hyperbola is xy equals k. So for our example, we're going to use xy equals 4. That is our table. Let's quickly put in our value. So the first thing we do is we take x and we divide both sides by x. Therefore, x will fall away and it will only be y. Y on that left side and divide by x on the right gives me 4 over x. This is the quick standard way that we're going to work out for y. So in each case, we are going to divide by our x value. So 4 divided by negative 3 gives me my y value. Again, we divide by negative 2, therefore our y value is negative 2. Divide by negative 1, therefore our y value is negative 4. Divide by 0 gives me undefined. Please see that if you divide by 0, you get undefined. So in this case, if you divide by x and x is 0, it would be undefined. If you divide by y and y is 0, x is undefined. Therefore, no matter which way around you go, x will be undefined on the axis. So, I'll show you that now. Okay, so x can't be, x and y is 4, divided by 1 gives me 4, for 2 is 2, and for 3 is 4 over 3. Okay. Let's draw the hyperbola. So there's our table again. Let's plot it. So in the first case, x is negative 3, y is negative 1 and a third. X is 2, y is negative 2, x is negative 1, y is negative 4, x is 1, y is 4, 2 is 2, 3 is 1. Okay, so that is our points for the graph. So if we now look again at our restriction says x is a real number, therefore it is a continuous function in terms of each of these. Okay, so the hyperbola has two continuous graphs. Okay, x can be any real number except 0 because on the x-axis and on the y-axis the other variable is undefined. Okay, so these are two lines. The shape of the hyperbola depends on the value of k. So if k is positive or k is negative, that will tell you in which quadrant it falls. So let's pretend that k is a positive number. If k is positive, it specifically goes into two quadrants. So let's just look at our equation, x and y equals k. So we are taking two values and we have to end with a positive. And these two numbers are being multiplied with each other. So the only way to get a positive answer is if x is positive and y is positive. Therefore, our first parabola can fall there. Our second one is if x is negative and y is also negative, because negative times negative is positive, and positive times positive also gives us a positive value. And there you go. Please, this is very good theory to have and you will use it until matric. The next point is when k is a negative value. If k is negative, it falls into the second and the fourth quadrant. Let's look at why. The reason for that is if we take a positive value and multiply it with a negative value, the number would be negative. So then k would be negative. If x was positive and y is negative, then x positive times negative will also give me a negative value, and therefore k is also negative in the fourth quadrant. Just please remember that x and y cannot be equal to 0, therefore the lines cannot touch either of the axes. And that is today's work. Please comment and let me know if there's something you don't understand or if it doesn't make sense. Have a lovely day. Cheers.